Hello and welcome back to the third installment of our ECS RTS tutorial series. In the previous video, we were able to get the unit to follow us on a right click, and we're going to build off of that in this video by adding a select system and maybe some interpolation so it doesn't look too jumpy when the units move around a lot. So let's dive into it. Well, actually, one thing is I organized our folders, so it was getting a little messy with everything just in one asset folder. So systems are in systems, scenes, components, all that good stuff. Utils has the blittable bool that we use. Other than that, everything else should be straightforward. I've added two classes that we're going to use today: player unit select component, and in our systems, player unit select system. So this is going to handle our selecting and things like that. They're just empty classes for now. Didn't want to spend time typing it. So we get into, actually we should start with the component here. So let's remove this, and it's going to be a struct of IComponentData. And we should probably add in using Unity entities. So there's actually two ways we can set this up. Player select unit select component could have nothing in here, and then we could just add and remove the component on the unit, and then thus the job system will filter anything that doesn't have the select component. Or we can just have like a public blittable bool is selected, something like that. Now, I posted this on the forum, and there was some good discussion there, and I think the conclusion was if you're adding and removing a lot of components, that's not good on entities due to caching and things like that. So I do predict that we'll probably be selecting selecting and deselecting a lot, so it makes more sense to just have this as a permanent component, and then they just add in, or we just flip this bool as they flip. That seems to be the better way. So now let's make this available in the editor. Let's remove this component, since that will be just the struct, and then we'll do public class player unit select component, and it's going to be a component data wrapper of a player unit select. And there we go. Actually, it's a class. Okay, cool. So now that this is done, let's go into the player unit select system, and I've already pasted my code here. So there's kind of a lot of changes, but I figured I will paste it and then just kind of walk through each step, so don't worry. It's not like a figure it out on your own kind of thing. This is a different way to do job system. If I pull up our input system, you see we have the job and then the iJob process component data, and then some of our component datas, and our on update over here in the unit select system. We're going to have our barrier system and iJob process component data with entity, and we're going to use a command buffer and some cool things like that. This might not be the most optimized way to run this, but I figured let's use a new API and see what we can do with it. So let me start from the top. So this is the same, but this is the first new piece of code that we'll run into, and it's called barrier system. Now barrier system, it just allows a synchronization point from our job system. If we go over to the Unity docs, we'll see barrier system is declared, which is what we do. There's no code, it just serves as a synchronization point, and then we inject it into the system and request command buffers from it. So you literally just need to add this into your code and don't even think about it after that. That's the only thing. You don't even initialize it. It does show up as a warning that's not initialized, but there's some magic that happens in the background. So for now, that's all you need to do. Now the next one is this iJob process component data with entity, and I have a second tab open here. So the whole reason of using that as opposed to component data is you can't access the entity manager in a C# job. So all this does is allows you to access your entities within your job positions, and this shows you. We don't use inject, but you get your component data from entity, and then you can just use it like normal. So that's the whole reason we do it, is so that we can actually go inside our entities and actually access that data right here. But before I get ahead of ourselves, so iJob process component data with entity. It needs a player input and a position. That's our player unit archetype. Now, you notice I don't have selected here, and the reason being is because we're going to use a new system a new way to filter in that selected stuff. Now, in a production system, you probably want to just add selected and check it in here, but for the sake of teaching, let's just do it this way. I'll get into these a little bit after, but execute is the same way, except we have two different things from our regular input system. So in the job process component data, you just have the reference to player input data in the execute. Over here, you have access to the entity and the index of where that entity is. So the job index, I should say. And then the other stuff is the same. So nothing fancy about the code over here. Since we have our player input, if we detect a left click, deselect everything. So if the selected component exists on our entity, remove that player unit select component, and then we actually recalculate down here. So I have a math distance right here, so the position. This is a little bit hacky, but it's the best thing I can do to kind of demonstrate the value. Basically, if our click is within the position of the unit, within 5 units, then we add the component, and add component takes a job index, the entity, and a player unit select component. So we have I here, entity, we pass it in, and a player unit select. So if they're within, we add the select. And then this is kind of normal. On update, well, not normal, but what we're used to on like the player input system. We make a new job. Now, here's where we pass in the command buffer. So from our barrier, which we injected up here, create command buffer, and then to concurrent. And for selected, this is where our get component data from entity, and we do our player unit select, and then we schedule the job as normal. So these are the two class components over here. And let's switch real quick to the documentation. So the reason we use the entity command buffer solves two important problems. When you're in the job, you can't access the entity manager, and when you create an entity or add a component, you invalidated all injected arrays. Now, basically all the entity command buffer does allows you to queue up those changes so that you don't basically mess up the job system. And they show some of these from the old two-stick shooter example, where you can create an entity and set component. So this is normally how you can call entity command buffer, or sorry, make changes to entities while in job systems. So all of this is in the Unity Technology Component System Center samples. So I'll post that in the description of this video. So now that we have our system and our component, all we have to do is make one tiny change to our player unit movement system, because before everyone was just moving regardless of if they were selected or not. So all we have to do is just filter anyone who doesn't have a player unit select component. And it's going to complain because we don't have a ref player unit select. So selected. We're not actually going to use this because anyone who's not selected won't be processed by this job. So now we can go in and test that real quick. We don't need to add it because we add it through our new system when they're selected. So that's just a different way to do that. So let's press play. Now when we right click, it doesn't move, which is what we wanted. But if we select this, let's go into the entity debugger, and let's go to player unit select system. And it looks like we do have, or sorry, player unit movement system. So now we do have one entity running in this system that has the player unit select. So we know we're successfully selecting, and now we can right click. And then if we click out of here, there's no right click happening. So this is good. Our selecting is finally working. Of course, it's a little janky right now because we're just setting the position to wherever the mouse click was. We're not really interpolating. So let's fix that. So the reason why it jumps around, as I said before, is once we right click, we're just setting the position of the unit to the mouse position. But we need some way to track the final position and then slowly move there against some time component like delta time. So this is where we're going to create our kind of the brains of our unit, and we're going to call this the nav agent component. And when I was thinking of the different approaches I could have taken, I like this one the most because we can put other information in there, like the status, if the unit is idle, moving, maybe even attacking, and some other useful stuff. I won't want to make it too big. It's not good to have massive components that do everything. That's how you run into problems with ECS. You could have like a attacking component, you could have like a final destination component, but all that is kind of expensive, and having one component kind of handle majority of that is kind of beneficial. So let's just copy and paste from a previous component to save some time, and let's just call it nav agent. Copy and paste. There we go. So now we have our nav agent, and we're only going to have two things in here for now. And of course, this will grow as we kind of figure out this RTS stuff. So it's going to be a float3 final destination. That's how we're going to track our final destination. And then we're going to have a status, and we're just going to make it enum super quick here. So public enum nav agent status, and we're gonna just have idle and moving for now. Okay, and then here nav agent status, we'll just call it agent status. So now we can track if we're idle or moving. This we're not, I don't think we'll use this right now, but it might become useful in the future. And then the final destination. And so let's get into our player unit movement job, and instead of setting the position, we don't need this anymore. We can completely get rid of this, and subsequently get rid of it up there, and then we're gonna add our nav agent here, and then ref nav agent, nav agent. And so what we're gonna do is set nav agent final destination to the mouse position when we right click. Player unit movement job might not be the best indicator of this, but since it's the player input is right clicking and we're setting the final destination, I think it's fine to call this system for now. Maybe in the future we'll clear that up, but I don't like to optimize too early. And now we need a system for our nav agent, and all this system is going to do is look at the final destination, and if we're not at our final destination, continue iterating towards it in relation to the speed. So nav agent, just nav agent movement system. And of course you can call this whatever you want, doesn't really matter. Again, we're going to probably just copy from the same system because save time, and there's nothing different here, just the core of it is going to change, as well as the names. So let's do public class nav agent movement system, and we'll do nav agent movement job. Nav agent movement job. And all we're actually going to do is, all we need rather, is the position and the nav agent. That's the only two things. Generally, it's better to have your jobs process as little as needed. It saves on, processing power and all that good stuff. So let's do position. Okay, cool. So that is good. We don't need any of this. And lastly, change this. So now that we have just the position and the nav agent, we need to calculate a couple of things before we can start moving our unit. We need the distance to our final destination. So we're gonna if you don't have the math library, let's bring that in. Mathematics. And there's actually a helpful new one called distance, and we're going to do, normally it's end minus start, so we're just going to do nav agent final destination to the position value. So that's our current distance to the final target. And then we're going to also need, actually not the normal, the direction of where we're going, so that it's not just going off in one direction. And that's going to be math, and we want to normalize our end position, which is nav agent final destination minus the position value. And so that's how we normalize it. So now that we have these two things, we can finally set our position. So if let's just pick a number. Our distance is less than 1, and let's say if we're not there, if our distance is not less than 1, and I guess for now, actually let's use our nav agent system. So here's, we set the final destination. Let's just set nav agent status equal to nav agent status moving. So this tells our nav agent that you are now officially moving. Let's go in here, and then let's say if our nav agent status, if our nav agent status is moving. So something else didn't change it to, like, frozen or paralyzed, depending on what your game is. Let's do that. And all we're going to do is just position value, and we're going to add to our value. So this means plus equals this current one, and we want to add the direction times it by I guess a speed, so let's just pick 5 for now, plus our delta time. So this makes it frame rate independent, so we have this public float right here, and then all we need to do is pass it in there. And so d delta time equals time delta time. And if everything processed correctly, we should actually be able to test that right now. So let's just do a couple things in the editor, and we should be good to go. So in the player unit archetype, we actually need to add our nav agent component. I already added it here previously. So we have idle moving. You can set, you probably just want to leave it idle. So you'll need to add that. If you don't have it, check to make sure that your component data wrapper is correctly there. And let's actually make 2 unit spawners. So Control D to duplicate. And let's move it a little off to the side. Let's move our unit spawner a little bit off to the side. So we have 2. And what's left is press play. So we now officially have 2 over here. And if we click and write, that is looking relatively smooth. And we can click here, and so everything is looking good. And we finally have our little smooth iterate moving around and all that good stuff. So thank you guys for watching. In the next one, let's get a little bit more polished. Let's add maybe like a new prefab to show that it's highlighted, so you know which one you're actually doing, and maybe let's make this a little smoother and allow them to rotate, rotation and heading. So stay tuned, and see you guys in the next video.